Everybody, can I have a hands down for Dmitry? The last talk of the event. After that, I do not leave because we want to take pictures with whoever survived the entire event. The last people standing, yeah. Okay, Dmitry, go.
Hi guys, I'm glad to see you there. My name is Dmitry Dygalo and I'm a tech lead at Kiwi.com. I live in Prague in Czech Republic. I love Python and do open source. So currently I'm working on splitting a big monolith into small handy microservices. And basically this kind of activity often goes together with a lot of refactoring and fixing some old problems. So if you are starting from the beginning, why not to do things right? So I will tell you about some important aspects of testing and goals that we are trying to achieve by doing testing. So what we had before with this monolith, what problems we were facing, and what alternatives we had. So what are the next steps and what are results that we have so far? Okay, so it's really important to have your tests isolated because one test failure should not affect others, and you have to have an ability to run any subset of your tests. Also, you need to reproduce your errors in your test suite, and you have to do it fast because usually if your tests are taking like more than 30 seconds, you're switching your context and you're just slowing down everything. So our stack usually looks like that. In the monolith, we are using Python 2.7. In our new microservices, it's usually Python 3.6 or 0.7. We use Flask a lot together with Connection. It's a framework that wraps up open API schemas. We use SQL Alchemy and Postgres, and PyTest for testing. So our usual example project structure is we have tests separate from the project code, and usually it's like settings, some database connection code, application, and some request handlers. Our settings will look like this. Basically, it's a bunch of global variables that read from environment during the import. Our database-related code, it was just a creation of some engine for SQL Alchemy and scope session, and we also had it on the module level, evaluated also on import. Just request handlers were super simple. We have an SQL Alchemy model. We are passing some data inside, and we are just committing everything. And to get some instance, we are just looking by primary key, so nothing special. Our application was also on a global level, so also another variable. And naive tests could look like this. So we are just asserting if everything is saved correctly, and that if you are looking for a non-existing object, it should not return anything. So what are the problems here with such approach? First of all, let's look into settings. It's just a couple of variables that use OS environment during the import. And to understand what is a problem, let's look in importing system in Python. So first of all, when you're importing something, Python checks cache in sys.modules. So if you imported something before, it will be taken from cache. If not, Python will look for some meta information like absolute path, parents, and stuff like that into spec. And then we'll initialize a new module, and we'll assign some this meta meta information from spec to this new object. Then this object will be cached, and the code of the module will be executed with exec. So, and then the module will be returned. So the key points are that modules are objects as well. The code of module is executed in a certain context, which could be different from what you need in your tests. Modules will be cached, and the cache could be polluted even if some error occurs. So it's not an atomic operation. So we also had session on the global level as well, but let's look how SQL Alchemy works inside to understand how we could learn from it to avoid these problems. First of all, sessions are lazy. The session factory are just passing through to thread local registry, and all methods of session are just proxies. And they are instrumented just like that with set attribute. Besides that, sessions are thread local, so each thread will use its own session, and they're lazily evaluated as well. Session itself uses identity map, so it's basically a cache between your application code and the database. So it's basically a dictionary and a set, and it uses weak references, so your objects will not be kept alive just by having them in cache. So what do we have after our first test? First of all, settings and database are cached in sys modules. Identity map is modified, and changes are committed to the database. So if you want to implement something global, you have to think about the following points. First of all, modules are cached, and they could be executed in different contexts, not what you need in your tests. It's nice to think about lazy execution and have these objects thread safe, and also weak references could help you with memory leaks. So how we handled all of these issues before? Initially, we overused monkey patching. So we were just creating a new engine and new scope session for our test suite. And in our tests, we were just monkey patching the module with database with this newly created object. We were running the test and making a rollback after it. So what's wrong with this approach? Basically, complexity grows really, really fast, especially if you have large code base. And your tests are weaker because you don't test actual objects. You're testing your mocks or object that you're creating during your test. Consequently, your coverage is decreasing for the same reason. And your test suite becomes more fragile because if you forget to mock something, for example, real session, it will be used and your global state will be messed up just by using two different sessions. And it also could affect your test suite running time. So basically, I'm not saying that monkey patching is a bad idea, but it's often overused. And it could fix some symptoms, but it doesn't fix the problem itself. And also, there are some better ways for handling this stuff. For example, with Flask, you could utilize deferred initialization with Flask SQL Alchemy extension. So initially, we just replaced our global object with another one, which includes some teardown logic and some helpers. So we modified our fixtures in the following way. We created an application. And for our test session, we just initialized this extension with our newly created application. We created all tables and after that we just dropped everything. So, and for each test case, we just don't need monkey patching anymore. So it's almost the same, just without monkey patching. And it gives you some flexibility because you can manage when do you want to initialize your database stuff. So you have an ability to choose when to do that. And you don't have side effects on your imports. And you don't have monkey patching because it's just, you don't need it. Also, it's really nice to wrap some logic that you have on the module level into factory. So here we have Flask application that initialized inside the function scope, and the database extension is also initialized there. So we could modify our test suite with this application factory, and the rest will be the same. So here we have more isolation because, again, we don't have any side effects on import. So we create an application instance after the test session starts, and you have more flexibility because you can choose what to do with this object during your test session. You could parameterize it, for example, using PyTest parameterization features if you need to test your application in different contexts, different environments, so you have an ability to do this easily. Another option that you could use is dependency injection. So instead of using some global object, you could just inject the session inside your handler, just directly. For example, in Redis Py, there is a nice example of utilizing this feature, this approach. So in strict Redis, you have connection pool that you could just pass inside, and it's really, it plays nice in testing. So in tests, they have the following. So basically some mock object that is passed inside of the pool in tests, and they just assert some insight of the pool easily without real connection to Redis. So it could help you. As an alternative, you could look for, basically it's decoupling of execution from its implementation, so you're isolating some logic in some different object, and if this stuff is kind of heavy, it could be useful because you could just mock it. If it contains some heavy CPU-bound computations or some network requests, you could just mock it easily. And as an alternative, you could try multiple inheritance approach, which is basically not the same, but really similar. You could create a session factory, create this engine and session in a separate method, and use it in booking factory. It's almost the same code. And for your tests, you could create another class and just use it as an mixin and just replace real engine and session with mocks. This approach was really nicely described by Raymond Hettiger in his talk on PyCon 2015, Super Considered Super. So it's really nice. Check this out. Okay, so we kind of fixed some global state issues on a Python level, and we still have the database. And when you're dealing with database, you have to choose what level of isolation do you need. For example, if you're working with some complicated setup and tear down that is really, really complex and could be really taking really long, it could be easier just to create a new database for each test case and not bother about this tear down and all this stuff. You could easily achieve it with testing.PostgreSQL package. So with this feature, you could create a new Postgres instance for each of your tests and use it in our application feature that we defined before, just like that. And for each test case, you still need to create your tables and stuff like that. So, and you have a new database for each test case. But it's kind of slow because it's not for free. And if you want more speed, and you could sacrifice some isolation, you could try, for example, truncate all data for each test case. To achieve that, you could just define database once per session, and then just delete everything from all of your tables. For example, in Django, there is transactional test case, which does the same. Basically the same, it uses truncate, but logically it's the same approach. And it's useful when you're dealing with something that you can't wrap into a single transaction and just making a rollback in the end. So maybe multiple commits, rollbacks, some logic like that. So we could utilize this approach. And the fastest one is just wrap everything, every test case into transaction. So it's exactly that we had before. And in Django, it's test case. So it's the same logic. Okay, all these approaches are included in PyTest PGSQL package, which is really nice and super easy to configure. Check this out. Also, if you need to speed up your test suite, you could consider putting database into memory, which is really good speed up your test suite. Also, you could just disable everything that you don't need. PyTest PGSQL allows it easily. So you could just disable all logs, everything, write-ahead logs. It's not needed. Also, you could use database templates if your modules are complicated. If you have like thousands of modules and it takes so long, you could just create it once and reuse it as a template, for example, in PostgreSQL. It's quite easily achievable. Or you could reuse existing one. In Django, it's keep DB option, as far as I remember. So it's the same approach. And if you have isolation and independence, you could just split your test suite and run it in parallel. So basically, by applying these things, we just really simplified our code base. We just dropped all the things that we don't need. All the smoking just disappeared. And we have much less unused code because we checked our code coverage and we discovered that many things are just not executed never because it's not possible to get to this point. Also, we had just really fast tests in our new microservices. All of the test suites are like less than 20 seconds. And we have much faster code reviews because many of errors are just really easily visible. So it's much easier to proceed with code reviews. So as a conclusion, you have to be aware to achieve some isolation and independence in your testing. You have to be aware about side effects and imports. They could really make a lot of noise and a lot of mess. It's really nice to utilize lazy execution, so to avoid side effects on import as well. So you have to clear your caches because they could be polluted in many ways, including sys modules. And weak references are your friend in this case, so it could help you with some memory leaks. And don't overuse monkey patching. It's not a bad idea. At some point, it's a good solution, but it depends on the context. I would say that it's more important to go to a simpler version of the code itself than apply something more complicated to make it work. So it's better to look into the root cause of the problem. Dependency injection is a nice thing if you want to test something in isolation from some heavy computations or something like that. And you have to choose your database strategy. So depending on your need, you could just adapt everything in the way that will work for you. Thank you, guys.
Thank you very much. Thank you very much,
Thank
Dmitry,
you as well.
for the last talk of the event.
Questions?
Oh, let's do it. Yeah, we have like a lot of time. 10 minutes. Okay, here you go.
Thank you. It was really nice talk, a lot of nice insights. So you said you have test suites that run from 20 seconds, but I'm not sure I got those tests are writing to the database or they're not touching the database?
Yes, as well. Into two databases.
Into two
actually.
databases. And what about the number of the tests?
Currently, the project that I was talking about with these two databases, we have like 150 something. It's not a big number. It's not a big project. But just to compare, in other project I had like 30 minutes testing suite, and just by cleaning up all the stuff that pollutes our code, like caches and all things like that, it reduces just 2-4 minutes. So it depends on the case, but it could be really beneficial, especially if you could run it in parallel. Could be really nice. It depends on the concrete situation, but it could be really, really nice. So
Thank you. All right.
Wait, there's a question on Slida.
There's a microphone.
Do you have
Okay.
end-to-end tests?
Depends on the project. In my previous place, we had a lot of them. So it was Selenium-based stuff. So yes, but currently in this, in Kiwi, in my project that I'm working on, it's mainly tests like that, so it's not many end-to-end tests.
And one more. What what do code reviews look like in Kiwi? Oh my god.
Oh. No. It depends. But respectful, maybe? The most important word that I could
Maybe
use.
we should ask the audience, do you know what a force push is?
Yeah, pushing to master and
Hold my beer.
no ask questions. It's usually quite tough in my team. No code without tests and stuff like that. So we are trying to have some high standards in it. I can say about other people, but in my team we are trying to make the best.
Thank you very much.
You're welcome.